So on the first one it says the two positive numbers, so the sum is 34, so that would be maybe an x plus y equals 34, and we're trying to maximizing the product. Well, the product is x times y. So when we're doing this, like I want to maximize this thing, but it's in two variables. So why don't we manipulate one of these? Let's solve for the y value. You could do it either way, but I'm going to solve for y. And now I'm going to get my profit equation is x times 34 minus x, because I substituted what y is, 34 minus x. So now I could graph this and find where that maximum occurs. It'll give me an x value, where it occurs, and then I could take that x value, plug it in to solve for y. So if we were graphing this, we'd get 34x minus x squared. Pretty sure we're going to get some type of parabola that's going upside down since I have this negative x squared. I'm going to go to my Desmos real quick just to get a general idea of what it looks like and where it's located at. So on the graph of this, I get something that looks like this. So we get this maximum up here. So if we take that derivative and set it equal to 0, so the derivative of that profit equation is 34 minus 2x, and we solve it for 0. So set this equation equal to 0. So I get negative 2x equals negative 34. I get x equals 17. And now to actually find that maximum profit, I have to take 17, plug it back into this equation, and I get a pretty large number. Let's see if I can, I think it's going to be 289 if I'm not mistaken. And it would be a 289. So on a problem like that, we have to set that equation up. We have to manipulate this piece. They've given us something that we can manipulate, but plug it into the thing we're trying to minimize or maximize. Let's look at another one that they're asking us about, and I think we looked at number 4. And so that one's dealing with the open box, right? So you have this open box. You are cutting out these squares at the corner so we can fold up the sides and make a box. So again, our volume that we're trying to maximize is length times width times height. Now, I kind of have to figure out, well, what's my length, what's my width? They told me that I had 18 inch by 18 inch. So all the way was 18. But each one of these things I'm cutting out is x. So if I look at this little piece right here, right? So this piece in between, that would be 18 minus 2x. Well, that would be the same thing over here because I'm cutting out these distances of x on both sides, right? So this distance here, that base of the box I'm making, would also be, this whole thing's 18, but minus that x and that x would be an 18 minus 2x. So I have my length and my width. So I have 18 minus 2x for my length, also for my width, so I'm going to call it squared. And then my height is x, because if I fold up this piece right there, it's going to have a height of x. So this is my volume equation. This is what I want to graph and then find what value of x gives me the maximum volume. And then one more, we talked about the right cylinder and coming up with a cost equation. So these are fun. You have to get the geometry out of here. So the cost, I have these two things at the top, right, that has some radius, two circles at the top. So for the area of those circles, I get pi r squared. But there's some cost associated to them. So I think mine was 2 times the cost of constructing the sides. So I'm going to multiply it 2 for the cost. But I also have 2 of these circles, so I'm also going to multiply it by 2. So 1, 2 is for the cost. 1, 2 is because I have a circle on top and a circle on bottom. So this is my cost equation. Now my cost comes from the sides. Now if you unwind a can, its sides looks like a rectangle. So the length of that rectangle is the same thing as the circumference of the circle, so that would be a 2 pi r. And then there's a height that's associated with it. Now, we were told in this one, you're designing a soft drink container that has a shape of right circular center. The container must have a volume of 16 fluid ounces. So the volume has to be 16 fluid ounces. So here's another equation. So I have volume equals pi r squared times height. Well, if I know that the volume is 16 fluid ounces, I could solve for h. So h is 16 over pi r squared. And that helps me figure out that this h is equal to 16 over pi r squared. That helps me find out what I need to add to my cost equation. So I have everything in terms of r now, because I have my two circles, which is 2 pi r squared. The cost is twice as much, so I just put a 2 out in front. So my cost on my lateral side is just one of them. But if I multiply my length times my width, I think there'll be some canceling out, and I end up getting 32 over r. That should be right. 2 pi r times 16 over pi r squared. So that one cancels out that. The pi's cancel out, and I get 16 over r. Oh, 32, because I have the 2 and the 16. So here's my cost equation that I'm dealing with. This is what I want to minimize on this particular problem. It's a minimization problem. So come up with these equations can be tricky / fun. So